Good morning, sir. I am Harshit from first second ECE department. Today's my topic is receiver model and noise analysis and understanding how noise affects and receiver performance. My roll number is 234g1a0443. Receiver model and noise analysis impact on performance. This presentation provides an interview of noise in receiver systems. We will explore how noise limits is performance of communication systems. Our goal is to understand how to analyze and mitigate noise. By doing so, we can improve receiver performance. Basic receiver model is signals journey. Components, signal flow and parameters. A typical receiver includes an antenna of RF amplifier. It also contains a mixer, if amplifier and demodulator. Signal flow. The signal flows from the antenna to baseband through each stage. Parameters. Key parameters at each stage are gain, bandwidth and impedance. And they have sources of noise in receivers. And there are four types of sources. There are thermal noise, short noise, flicker noise and external noise. In that first one we can discuss about the thermal noise. In thermal noise, random electron motion generates thermal noise. Resistors in amplifier circuits are a major source. Short noise. Random arrival of charge carriers create short noise. This occurs in semiconductor junctions. And next is flicker noise. Frequency dependent noise prominent at low frequencies. Operational amplifiers exhibit flicker noise. External noise. Atmospheric and man-made interference can impact receivers. Urban settings have significant interference. Noise figure NF and noise temperature TE. And these also we can have three types. There are noise figure, noise temperature and cascaded NF. Cascaded NF means cascaded noise figure. In then NF means noise figure. Noise figure is the degradation of SNR from input to output. An amplifier with NF is equals to 3 dB degrades the SNR by a factor of 2. And then second one is noise temperature. TE is the equivalent temperature of a resistor generating the same noise power. An LNA with NF means noise figure of 1 dB has a noise temperature TE of approximately 75 K. And then third one is cascaded NF. The overall NF is a multi-stage receiver. A receiver with a first stage LNA has a total number of dominated by the LNA. Impact of receiver on noise on receiver sensitivity. Sensitivity, noise flow and relationship. And then first one is sensitivity. Sensitivity is the minimum detectable signal level. It's the input signal power required for a specified output SNR. And then noise floor. The level of background noise in the receiver defines the noise floor. Lower noise results in better sensitivity. And then relationship. Lower NF leads to improved sensitivity, allowing the receiver to detect weaker signals. Dynamic range and noise. In that first there are three types: dynamic range, limiting factors, noise impact. And then first one is dynamic range. Ratio of maximum tolerable input signal power to minimum detectable signal. And then second one is limiting factors. Noise floor sensitivity and distortion, example 1 dB compression point. And then third one is noise impact. Higher noise floors reduces dynamic range. If a receiver sensitivity is 100 dBm and its maximum input signal is 20 dBm, the dynamic range is 80 dB. dB means decibels. Managing noise is a crucial to maximizing the dynamic range. Techniques for noise reduction: LANs, filtering, shielding, and colded receivers. First stage amplifiers with very low noise figures LNS improve receiver sensitivity. Reducing noise bandwidth using filters is important, so filters reduce out of band noise. Preventing external noise from entering the receiver, metal cases enclose sensitive components, and reduce thermal noise by cooling components used in radio astronomy. Conclusion: receiver performance. We covered noise sources, noise figure, temperature, sensitivity, and dynamic range. Noise analysis is a crucial for achieving desired performance. Ongoing research focuses on low noise components. Noise cancellation techniques are also advancing. Thank you, sir.